This is a long weekend, and during this weekend there will be a number of social events and also chatting and maybe we'll do some purchase orders, and a little bit of prototyping, or at least building models on cardboard and string. So stay tuned. The execs will, I'll let you know when it will be. Most of the non-school activities will be at my house. If there's a sleepover, the boys will have a sleepover at my house, and the girls will have a sleepover at someone else's house. But they're only about 3 blocks apart, so this is a street.
Yes.
I could go now. I have 2 other people in my group here right now, which is not exactly ideal, but like at this point I guess.
So you're gonna have to run. I believe so.
Is it to go? So.
Yeah, let's go.
Cool. Okay. What do you guys all want? All 2 of you. Okay. So we are design group number 4, right? We'll look over. Okay. So we are robot design group number 4. Our mentors were Dan, Chuck, Rear, and Lenora, and these are all our students. Got it? Cool. Okay, so our goal for this season, when we set out to design this robot, is to be an Alliance Captain at Worlds, right? 2014, we made it there. In 2015, we made it there. We were an Alliance Captain. We want to be at least back at that level that we were at 2015. Now, what does that take? When we look at this game strategy, we think that a lot of these things are true. This is not the slide that I expected to be here. So this is kind of the thought process behind the game analysis. Dick thought about how long things are, how difficult they are, right? What kind of mechanisms you're going to need, all this good stuff. And I'm sure I could go into a lot of detail about it, but I'm going to spare you that. And just move into the decisions that we actually made for robot strategy in this game. So these are our main functions that we wanted to have, right? We think top teams will need to be able to deliver gears, obviously fast, right, and efficiently. Pick fuel up off the ground. You want to hold at least 30 fuel, but preferably more. We're thinking in the 40 to 60 range. And then score fuel as well as a climb at the end of the match, which we think will be crucial, especially as we get towards the end of the season and we're playing in higher level play. So overall, regardless of mechanisms, these are the 3 qualities that we wanted our robot to exemplify. Right? I think as a team, we kind of decided that we wanted a fast robot this year, which is not exactly what we've had in the past. And reliable kind of speaks for itself, right? We want a robot that always does what it does without breaking. And distinctive. So in getting picked, in having the robot noticed online, in the pits, and in general, you want to have a distinctive robot that doesn't just blend in, that people notice. So these are some of our robot design elements. I'm going to be throwing it off to some of these guys as they talk about some of the elements that they're passionate about. Drivetrain. Okay.
It's tough when you have the group
Okay.
and make it.
Yeah.
Wait, what? Never mind.
Go ahead. Go ahead.
Okay, we're using West Coast Tank Drive. First of all, because there's going to be a lot of defense play on the field. And secondly, yeah, basically the most important part is reliability and also the speed.
Got some low gear, high gear speed calculations, and it is worth noting that we did consider an H drive, but ultimately decided that, as Grace said, the pushing and what we expect to be the defense in this game just outweighs the benefits of the H drive. So onto the floor pick. That's on you guys. Right? Okay, I'll do this one. Okay, sure. Go ahead.
So we decided we wanted to do an over-the-bumper intake because we thought that it would just be a lot more, it would be more useful to have all of our bumpers there. And, well, we could pick up multiple balls on the floor at once using the width of the bumper. And the rollers are going to push the balls against the bumper to create friction to suck the balls in and then into the bucket so we can then fire them.
And just to add one more thing there, actually, I must have edited the wrong version, but there was one more thing that we wanted to add to this, which was that we were thinking about having some kind of mechanism, passive, on the front of the intake that would kind of corral balls as we drive forward. Because I think in the higher levels of this game, you envision it being a field that's pretty crowded with balls. And so being able to pick up 10, 20, 15, who knows, as you go across the field, will just decrease the cycle time. Loading station intake. Okay, so this is Gideon's. Okay, so we designed this loading station intake that will work for both gears and balls. So as you can see here, the gear falls into the slot, which you probably load first, and then the balls will jump over that gap, probably hitting the top of the gear as it goes over. So we favor this mechanism because one, it's passive, and two, it handles both the gears and the balls pretty well based on some like really primitive prototyping that we did yesterday. And yeah, there's a bunch of different ways that you can do you can have the gear release, but we'll get to that a bit later.
So for the climber, we were thinking about a similar idea to Team Robot in 3 Days design. That's basically a spinning drum attached to a robot. Yeah. And yeah.
With Velcro. Velcro's important.
Yeah.
We're still waiting on the real quick.
So far, it's still legal.
Yeah.
For the shooter, we wanted to go with a turret that can spin in 360 degrees, so wherever you are in the field, we can get from any angle. And we also wanted to have an adjustable HUD, so for how close and how far you can hit it from anywhere. And for the wheels, we wanted to choose Colson wheels because they last a lot longer than our average wheels.
Okay, so this is probably the most distinctive feature of our robot. So Ethan did mention a turret, but it's not really a conventional turret. It's not a turret in the sense that the upper shooter assembly moves. It's a turret in the sense that the entire inside hopper of the robot moves. Right, so we've seen this with designs from 2006, I believe, where you have this ability to not only have the turreting motion of your shooter, but have an intake that loads like 2, maybe even 3 balls into your shooter at once. So we've seen this design, Team 121 from Rhode Island was able to do it pretty successfully in 2006. And being as this is a similar game to 2006 with lots of balls needing to be shot into the goals, we think that this could be a really helpful system, combining the ease of a hopper and then the turret that we think you'll need in this game. I think that's all we got, right? Yeah, that's it. So thanks for listening.
Any questions?
How are you going to aim your turret?
Software?
Where's the camera going to be?
So as far as aiming the turret, there's a bunch of different ways you can do it. You can do a really big gear, but
No. I don't mean how you turn the turret.
Cheesy food style.
Do you mean mechanically or software-wise?
Where does the camera sit?
Yeah.
Guys, one at a time, and try to let them answer. Remember, they don't have a full design, they just thought it through, so let them answer.
Keep in mind, if the camera's in the turret with the shooter wheel, what that did, well, you weren't here in 2013, but the camera view shook so much it was useless.
I do have a thought.
Go ahead. Okay, I think I would ideally like to have it mounted on a frame piece rather than something that shakes, but we didn't really consider that much in detail with the camera, but I'm sure we can solve that problem.
Okay. The two volumes, did you pick one by any chance?
Yes.
The-
We picked the taller volume. It's scary. It's extremely scary to me actually seeing it in real life. The small volume, it's just so incredibly small. But yeah, we still think that gives us the most room for hopper. Yeah, sure.
Can you explain a little bit more on sort of the hopper that rotates as well? So generally, traditional hoppers are very big, sort of just square that goes into. How does it sort of like do the entire thing?
Yeah, so this would be a circular thing. I don't know if you can how well you can see this picture. You can go look up this robot, but it's a circular hopper, right? And they basically just ran it with a wheels on both sides that run against the bottom of the hopper. And so certain parts of the hopper will be cut out. Like for instance, there's the part where we demonstrated that our we would load from the feeder station, there would likely be a cutout to allow balls to enter in from that place, and probably some kind of cutout near the bottom to let the intake feed balls in the hopper as well. Now here, Benji.
So you mentioned something with
Speak
the
up.
intake that extends over the buffer. So
Repeat.
do you have a solution for how that might avoid getting broken and damaged during normal robot play, or might give away during activating a hopper or whatever else?
Cam, repeat the question.
Okay, so Benji asked, with our intake, our over-the-bumper intake, are we going to have, do we have a solution for the defense that we will inevitably face? Yeah, come on. Do we have a solution for the defense that we'll face? If any of you guys want to answer these questions, feel free to jump in. It doesn't matter.
Yeah.
Do any of you guys want to answer this question?
Definitely distinctive. Cool.
Well, I mean, I guess the intake mechanism, because it's outside of the bumper, it will have to start inside of the bumper initially. So something that could work is just to have some sort of pneumatic device to lift it up. And that would also stop it from being damaged if we ever run into gears and we push them around.
Yeah, so we could have it lift up is one option. Or just built it to be pretty rigid. It's worked for other teams.
It's not that big.
Why did you choose to have your ball rotate as well? Like last year, Code Orange had a similar design to that, but they would bring balls up, but they only had the turret rotate. Why did you choose balls like that?
So there was a struggle between two different things that we really wanted. We wanted turret shooter because we feel like it's going to be big for auto, shooting a lot in auto, and just in general, right? But then there's this, on the other hand, you want your shooter firing really fast, okay? And so I think the way to do that, and I haven't seen all the Robot 3 Days videos yet, but I think the way to do that is with a multi-ball wide shooter. So we wanted to have like a 2-ball wide shooter. But then you encounter a problem when you try to do that in the traditional way, because usually when a turret rotates, it rotates around the center point, right? And you can have balls come up right through that center point. But when you have a 2-ball wide intake, you lose that ability to rotate correctly around the center point, and stuff starts to get really, really weird in there with all the geometry. If you're going to be easier, we just take this design, make the entire hopper move, and exchange misalignment up top for misalignment down at the bottom, where it doesn't matter. That's the trade-off that we're getting.
How big of an opening do you have if you're, I mean, when you hit the hopper on the field, 50 balls come out. Are you going to be able to catch all 50?
I would assume,
Yes, assuming 60% of the space is used up. I crunched the numbers and we should be able to fit around 80.
Yeah, but is your opening big enough for all of them to come slamming down into them, because they come out pretty fast?
Yeah. So this is one thing that we hadn't looked into a lot because we knew that we had some flexibility as far as designing this whole hopper thing. So it really depends on how large you want to make that cutout in the hopper. I think I could see it being 2 balls high, which I think would be easily enough to accomplish that fast flow rate right into the intake. And it's wide, about as wide as the robot is, that intake. So
Okay, and so
yeah.
which is the front of your robot the narrow side or the wide side?
The front of our robot would he's asking, is it the narrow or the wide side?
25.
It'd be the narrow
It's
side.
like 20. It's like 30 by 32, I think.
Yeah, it's 1 inch, 2 inches
Yeah,
off.
okay.
We basically treat it as being the same.
Okay. All right, good.
Thank you. That was great. Who wants to go next?
Cam, whale it tonight at the concert.
Yeah. Who wants to do next? Huh? You want to go next? You want to go last? Okay. What group are you?
4, 5.
No, you can't be 4. 4 just did it.
5.
You're 5. It'd be nice if you knew your group number. Eric? Eric? Where's Eric? You put ours on there too. Put ours on there. There's presentations on the drive.
If it's on the drive, it should be right
No,
there.
it's not in the same place.
Slow down.
I actually feel a lot of
Yeah.
Good?
Potentially walls, gears,
So, our analysis of the game rules. Speak up. Our analysis of the game rules showed that gears are a higher risk compared to ball shooting, but they can give you a very high reward. Because what can happen is you can spend all your time trying to get enough gears into the airship, but if you don't have enough support from your teammates, then it won't accomplish anything. Because you need 12 gears to get all the rotors turning, and if the other teams on your alliance just build ball shooting robots, then there's no way that you'll ever get that many. And you can't get, you need a lot of time like training the driver and the pilot to handle the gears properly. But like in the end it pays off because they can give you a higher maximum score in ball shooting.
High efficiency fuel is another way to get points, and if it is successful, if the gears are successful, it will earn more points than the high efficiency fuel. But with using the high efficiency fuel, there's less risk because with the gears, it's sort of an all or nothing type of scoring. But with high efficiency fuel, we can constantly get points by getting the balls in the goal. And it is possible to get a 40-point autonomous, although it is difficult with high efficiency fuel, but it is possible and we can do it by ourselves, which is important because with gears, we would have to depend on other teams because we need a lot of gears in order to get all 4 rotors turning. So we would also need to do a lot of prototyping with high efficiency fuel because the ball physics are sort of unknown because they have holes in them. So the shooter design is a bit uncertain.
Has anybody actually thrown one of these balls, tried to curve
Yeah,
it or
so
anything?
from all, I tried to curve them as much as I can, and from all I can see, they go straight.
No, you can curve them. Max and I had some nice curve balls, but it's not relevant to what we're trying to do. I don't think we're proposing to curve balls into the goal.
Let them talk.
So these are just some of our calculations on like what you get from scoring. And basically what it means is you're going to score more points from gears, but you're going to get more linking points from fuel, so just balancing those two. But basically what came out of this whole activity.
Okay, so this is some conclusions we made about our goals. So in order to increase point values for all designs, we need to come up with some climbing system because of its benefits. So in terms of shooting, in terms of other things that a robot could do, a passive gear mechanism along with the shooter would be more efficient than necessarily a floor pickup. However, that isn't out of the question. So high efficiency shooter is more efficient than low shooter, and we definitely need to focus on one of the two. And we're thinking high shooter definitely, and so basically just forget about low shooter essentially. So a shooter gearbot hybrid is more effective than a dedicated gearbot or a dedicated shooter. So that's one of the things, but there is a sort of balance there.
Yeah, so this is basically our robot description. So we wanted a high efficiency goal shooting robot that can easily load from the loading station and the hopper. And so we think that the ground is important, but not as important as loading station or the hopper. So that's sort of a last priority for us. And then a passive or semi-passive gear mechanism and a climber. And then just a standard tank drive system, no strafing or anything because of the aforementioned defense.
Wait, so in terms of loading from the hopper, that might mean that you have an accessible kind of top of the robot so that you can get as much out of the hopper as possible when you're going under there and getting all of the jumps in. You minimize the split. So this is these are the requirements that we want. So basically we had 3 different 3 different values for each thing. So a demand is like the bare minimum, like we need this for this to be worth developing. So, and then a prefer is like this would be better than you wish is like a stretch goal, like it's probably not going to be happening, but it's possible. Like we should strive for that. So for a drive speed, like we want like 12.5 feet per second. That's like what we demand. And 14 feet per second is like it's better. It's just the best we can do. And then in terms of climbing speed, like 20 seconds is basically like the minimum we need. It's like the ropes are only open 30 seconds. So there's not much point there. And 15 seconds is like what we prefer. 10 seconds is what we want. But some like the 3-day design robots, they're doing climbs in like 5 seconds. And then the gear mechanism, ideally we want like a gear that's like unjammable, but that's not really realistic. So what we want is when it does jam, we want to be able to drop the gear out of the gear holder and then just go get new gear. And then we prefer, like, in addition to that, to have like to be able to place it on the lift using the assistance of your software.
So for the robot mechanism requirements, if we have a low efficiency shooter, we demand that we have 7.5 balls per second so we can score enough points. We would prefer to have 12 balls per second, and we wish that we would have 15 balls per second. And for high efficiency, we need 2.5 because we would be getting more points in high efficiency. We would prefer to have 4 balls per second. That'd be nice. And we wish we could have 5 balls per second, which would be a bit of a stretch.